Good morning to all. Today class we will discuss about analysis of variance. Anova is a statistical tool that stands for analysis of variance. Anova was developed by Ronald Fisher in 1918. Generally, they are telling the extension of T and the Z test. It is one of the most frequently employed statistical techniques in social and engineering science because it provides flexible methodology for testing differences among means. Next, need for ANOVA. Hence, one can use ANOVA when the number of samples is more than 2 to check the effect of factors and the interactions of the responses variable. So each and every operations, every experimentations is a different. So depends on the how much factors we are taken. So based on the input variables to get that output responses. So easy to get that interactions between that factors. So in this point of view, ANOVA is more helpful. Since this analysis tool uses F-test, it will provide meaningful inference relating to the effect on the response variables. This tool is used very commonly business, medicine, psychologist. In business people, ANOVA can be used to compare the sales different designs based on the different factors. In psychology, researcher can use this statistical tool to compare the different attitude or behavior of people, whether or not they are the same depending on certain factors. In medical people to use analysis of variance for the effectiveness of drugs. So nowadays researchers are using ANOVA in many ways. The use of this tool depends on the research design. Commonly researchers are using ANOVA in three ways: one-way ANOVA, two-way ANOVA and n-way ANOVA. First, one-way ANOVA. When we compare more than two groups based on one factors, in these cases, so independent variables taken only one factor. This is called one-way ANOVA. Example, it is used manufacturing company wants to compare the productivity to based on only one factor. The particular factor is working hours. So in this case, we have to choose for one-way ANOVA. Two-way ANOVA. When a company wants to compare the employee productivity based on two factors, two independent variables, then it said we go for the two-way ANOVA. Example, so based on the working hours and working conditions. In the last previous case, we have to take in that working hours only. In the particular cases, the input variables, the two input variables have to taken working hours and working conditions. So in these cases, we have to choosing that two-way ANOVA. It help to find out the interactions between the factors. Two-way ANOVA can be used to see the effect on the factors after controlling for the other, or it can be used to see the interactions between the factors. N-way ANOVA. When the factor comparison is taken, then it's said to be an n-way ANOVA. For example, a productivity measurement, if a company takes all the factors for productivity measurement, then it's to be an n-way ANOVA. So initially one-way ANOVA had to taken that working hours. The two-way ANOVA, the working hours and the working conditions. In the n-way ANOVA, so number of input factors they are involved. So examples, if one company, the production company, so depends upon not only for working hours and working condition. So based on that people, say environmental. So n number of factors they are involved to get that productivity and also to get that quality of the product. So in these cases, should have to use that n-way ANOVA. So now we see one case study in relevant to that n-way ANOVA. In the particular case study, optimization of tick welding process parameters. First you have to see that selection of parameters and the levels. Here the experimenter to taken the three levels and the parameters. So welding current, shielding gas and W groove angle. The value is taken based on that previous reputed journals. Otherwise to based on that welder's experience, we have to choosing that levels and factors. There taken that L9 orthogonal array. So SA1, SA2 is a sample number. These are the input parameters. So they are derived that orthogonal array. So experimental results. So based on that to conduct the test, to get that output results. Here that output responses ultimate strength and Vickers hardness number. The experimenter to taken that three test for one samples and to taken that average. That average they are mentioned here. They are mentioned here. So then they are found that the gray relation analysis then found the normalized values and deviation sequences for that 9 experiments. Then to found that gray relation coefficient and gray relation grid. So based on the gray relation grid, they are awarded that rank 1 to 9. So finally, they are found that analysis of variance. So in this analysis of variance, the table have to collect from that Minitab software. So they got values only up to that limit only. So contributions we have to find out from the tables. So in these cases, so welding current their influence 57.46, gas flow rate 21.29 percentage, double groove 6.05. So in this process, the error 15.2 because of they are won't consider that welding speed filler electrodes. Maybe they are involved. So the experimenter is not consider that results. So maybe that's why to get that error values, it's huge compared to the double weak group. So how to execute that results with the support of Minitab software. So already last class we discussed how to enter that value in that spreadsheet. So initially we arrive so factors and levels with the support of design of experiments. Once you have to get that value relation grid, you have to enter or otherwise just you have to copy the Excel sheet and keep it here. Then you go for Anova. So this particular facility is only available that Minitab 18 versions, that provisions not available and Minitab 14 and Minitab 16. So students are asked to install the Minitab 18 survey. It will be help to extract that value from Anova. Anova, then you go to that general linear model. So general linear model, after that we choose that fit general linear model. Then you get that plot. This plots help to interactions between the factors. So this place to get from the analysis of variance already I shown here, here. So we not get that contribution value. We contributions to collect from that sum of squares. So students to want to more details to refer this journal.